look at another complex type of form. The hydraulic industry out there has a number of ports that have to be cut year in and year out. It's an enormous industry. This particular tool has the capability of drilling a tapped hole, okay, drilling the port contour hole, and then drilling the spot face that's associated with a port. Let's look more closely. Current methods, a lot of people are going in using a spot drill. Second operation coming in, they usually pre-drill for the tapped hole. Third operation, reaming for a tapped hole and then forming the port. Many cases, it could be a ream operation. Some guys will even have 4 operations where they're using circular interpolation for the various operations. Here we're doing it with one tool. We're using a replaceable tip on the front end. We're using a wraparound insert, of course, that has the ability to do the entire port form all in one shot and hold, of course, the ISO specifications for tolerance. I've seen these type of tools actually take port manufacturing time from as much as 20 minutes down to seconds. Okay, so the savings here is enormous. Let's look at some examples of, let's say, some work pieces that might be out there. Let's say you can use these type of tools in. I'm going to start with the automotive industry. Here's an automotive cylinder head. Of course, you've got water jacket holes that have to be cut, the spark plug hole, the cylinder head water jacket hole, of course, the bolt clearance holes are all over the place. Okay, there's a number of holes on here. Just to give you some kind of an idea, some multi-purpose drills that can go into this part, a guided TA with a customer-defined shank to go in and do your real deep hole water jacket hole. When you look at the actual hole that's being used for your spark plug hole, it's actually a drill and counter bore. Can be done in one shot with a replaceable tip on the front end and, let's say, some ISO inserts to do the counter boring on the back end. There's also a multi-step drill that's being used in order to form a plug. Okay, on the other side you have a drill. Of course, you got a counter bore and you got a chamfer that occurs on the top side of that also. How about an automotive engine block? You got oil feed holes, of course, that have to be drilled. You got the deckhead bolt holes that are there, the water galley holes. You got crankshaft bearing caps, okay, that have to be machined. You also have water jacket outlet holes that have to be done. Let's look at some of them tools. You got an IMTS drill that does a drill chamfer or drill counter bore being used. You have a wear padded holder designed to go in an interrupted cut and keep that hole straight and on position. You also have some guided TAs doing some water jacket, doing some oil galley holes. There's a number of holes that can be used, or a number of different drills that can be used on this particular block. How about the camshaft? You see one of the drills earlier on that was doing the balancing of the camshaft, but I got flywheel holes that have to be produced here. I got a clutch alignment hole. Okay, I got a timing pulley hole that has to be done. Timing pulley retention hole, balancing holes. Types of drills you might see a double angle being used in order to create the chamfer at the top of that hole. You'll see an ICS drill going in and creating a drill and countersink here. You'll also see some multi-step ICS with whistle notches, okay, to go in and do the center hole. Again, all tools designed to minimize the number of strokes you have to take in a workpiece. Let's look at a camshaft, and here goes a wear plate also. We got an oil feed hole that goes straight on through, has to be straight, and of course you got some timing holes that have to be done. Type of tools we're using here, we're using the drill chamfer, of course, to go in and just create the timing type hole, and of course then you got a guided TA going in and drilling straight on through. Let's look at multi-purpose drills in the wear tab, on the wear plate, okay? Here goes an ICS drill, of course, it's going in and creating a drill and then a countersink. What's interesting about this drill is the front end. If you notice, it's got a wear surface. In many cases, when your holes, of course, become too shallow or your workpieces become somewhat unstable, it's always nice to support the drill, of course, with some kind of wear surface. That wear surface in this case actually has to be a chrome surface, but it could also be a brazed carbide surface, could be a carbide bead. There's a number of wear surfaces that could be provided here, create the stability needed to drill with. Let's talk about rim drilling. We showed you one earlier. These are multi-purpose tools. There's a number of holes in rims that have to be done. You see a valve stem hole that goes in and actually does a drill and counterbore for a valve stem. You see an ICS spur hole The hole up through the center, of course, is where the aluminum's poured into. You have to open that up and then, of course, create a countersink there. You got lug hole drills, okay? These, of course, are the lug holes that have to be created for the lug holes to bolt down the rim. Of course, there's balance cuts, which you'll see on the right-hand side. The balance cut design allows for usually increased penetration rates in the form of you have the capability of, they're double effective, so you got double the feed rate capability. You have unbalanced types on the left-hand side down towards the bottom that allow one to drill. Then, of course, create the conical seat as well as the counterbore spot face that has to be performed in this operation. Enormous savings, increasing penetration rate as well as minimizing the number of tools to produce these holes. These holes are actually produced in a matter of seconds. All 5 holes here can be produced in about 3-4 seconds. Let's look at a hydraulic manifold. You got hydraulic ports, UNFs, O-ring type seals. You got deep hole drilling in order to intersect a lot of these hydraulic ports. You got a BSPP port in this particular hydraulic manifold. Types of tools. ICS using an AccuPort, okay, insert with a chrome pilot in order to go down, create a straight hole to the intersection hole as well as create the port form on the top. You got a guided TA drill with a customer defined shank going through and do your water galley holes. You got multiple step ICS drills and doing a drill countersink counterbore. Again, multiple operations, one tool. Let's look at a form insert. Another multi-purpose drill and insert, doing a flow elbow. Of course, the flow elbow likes to have some kind of smooth transition radius. The drill on the front end actually is doing drilling as well as creating a smooth radius at the contour. And then, of course, we have to make sure that we actually have something supporting this drill because, of course, the second side is interrupted. And we have to make sure we stay on size. There's a bull nose radius that's occurring with this, allowing one to have a radiused elbow. Here goes a valve. You got a valve stem hole that has a multiple step in it, okay? You got a drill through hole, you got a counterbore, you got another counterbore, and then you got a chamfer at the top of that. So there's actually 4 steps in this drill. Actually taking 4 steps down to 1. Enormous cost savings here. Let's look at the bolt holes that are on the front of this gate valve. You'll notice you have an ICS drill doing a drill countersink, and you notice you also have an ICS with a chrome bushing diameter doing a drill countersink. What's interesting to note here, of course, is the bushing that goes with the bottom drill, of course, designed to hold true position. Where it's critical, bushings may be needed. Drill bodies can be designed to manufacture or actually allow for that function to occur. So, again, more multifunctionality. Let's look at a turning operation. Here goes a conventional turning operation where someone has to drill into a part, solid material, create a flat-bottomed hole. They got 2 tools involved there, using an end mill to do the flat bottoming, a drill to do the drill portion. Then I got internal bores I have to produce, some kind of shoulders. I got a 3rd tool there. Then I got a turning tool. I got to turn the face, of course, and then at some point in time I got to turn the OD. Let's see if we can do it one tool. Here's a tool called the EcoCut, basically designed to do all 4 operations, okay, with one tool. Tool will drill in solid material and create a flat bottomed hole. Then, of course, come back and act as a boring bar in the same direction and do multiple, let's say, shoulders on the ID. Tool can then be used, of course, to do the face operation. And then, of course, with a simple reverse of the spindle, tool becomes an OD turner, and at that point you have all 4 operations. What's interesting to note, you'll notice on the next slide, my conventional stick tooling, I was using 4 tools. And of course, with my EcoCut, I'm using 1 tool. I just freed up 3 stations. Conventional tooling, I've also reduced my inventory. Where I was using 4 tool holders, 4 tools, and 3 boxes of inserts, I am now using 1 tool holder, 1 tool, and 1 box of inserts. What's also critical to remember, the other time savings that one can gain here is, of course, the programming time. When you look to the left, I actually had to create 4 programs. Now I'm creating 1 program, so I'm also saving time, of course, with 1 program. Experience has told us, of course, or has shown us that basically with this type of tooling you can save as much as 30–35% in your turning costs using this type of tooling. This is for small lathe parts you can normally hold in your hand, okay? There are a number of manufacturers that make this type of tooling. Now that we've shown you a bunch of different types of specials that are out there, okay, to make your life a little easier and reduce your actual manufacturing costs, let's talk about quoting systems. There are companies out there, we just happen to be one of them, okay, that actually does have online quoting to help you through this whole process. We actually put ours online on 2006 so that you can go in and you can actually design specials online, whether they be blades or holder bodies or combination of holder bodies and inserts and drills. They can be designed online, real time, with a real-time quote in your hand as soon as you hit the return button. It doesn't get any simpler than this, folks. Just to give you an idea, it's all menu driven, okay, so you'll go in, you'll start selecting from a menu, and as you go through, it'll prompt you for more things that you want to design into the tool. And of course, it's actually intuitive enough to know that something may not be designable, and it'll come back and give you other options.